Okay, welcome back to part 3 in chapter 10, picking it up now in communications devices with the cable modems. So essentially, cable modems work as digital translators. They receive these digital signals from an internet service provider, and then they immediately translate them into a digital language for your router to distribute across your local area network or your wired or Wi-Fi connection, as the case may be in your house or business. Now, let's see. Work for me. There you go. Okay, communications devices continued. So a Wi-Fi modem is a single device that combines the functionality of a modem and a router often, right? Making it a one-stop shop for this internet connectivity. A Wi-Fi modem is a single combined device then that translates these internet data packets we've been talking about via the modem and sends it through wirelessly to devices in your home via the router. Now, some smartphones function as a wireless modem when they operate as a hotspot. When your phone is used as a mobile hotspot, the phone acts as a wireless access point. And you can then connect, or tether it's called. You can tether your desktop or mobile computer to the phone. Remember, if you do this, try not to display your SSID and use a password for access. Now, there's more information on SSIDs, if you don't recall, back in Chapter 5 in the How To, Section 5-2. So a WAP, a wireless access point, is more generally just known as an access point, but formally as a wireless access point. This is a networking hardware device that allows other Wi-Fi devices to connect to a wired network. So it is centrally located and transfers data wirelessly using the Wi-Fi standard. So you'll notice your router at home probably is also combined as a wireless access point, and it has these antennas on the back. In an office building, if you look up at the ceiling, you'll see little boxes. A lot of times they're Cisco devices. They're wireless access points. A little white box with usually a little blue light in the middle is what I see most of the time. Those are wireless access points. Okay. Now, a router is a device that is designed to transmit all of the data not specifically denied between the networks. Remember, a router usually has a built-in firewall, so it can deny some of the traffic, right? But if it's not denied, it's going to transmit all the data that is allowed, and to do so in the most efficient manner possible. So when your data packets go to your router, they're going to go out to the internet. They're never going to travel the same path twice, possibly, because they're going to go by the most efficient means available right then. So a router enables connectivity between two or more networks, right? And you can, so if I'm talking to Walmart has a network, I have a home network, and now I'm communicating between these networks by the router. So you can connect multiple network segments even in one network using a router. So basically a router allows multiple computers and mobile devices to share a single broadband internet connection, such as through a cable or DSL modem. That's what's happening in our home, right? We've got this cable or DSL modem that comes in, and then the router is going to allow that broadband connection to be shared amongst various machines. Now, a modem versus a router. What's the difference? Well, your modem, again, is the box that connects your home network to the wider internet, right? That's what a modem is going to do. A router is the box that lets all of your wired and wireless devices use that one internet connection all at once, and it allows us to talk to one another without having to do so over the internet. We're using a router. Router may be able to connect 200 or so wired or wireless computers. Just know that the more you add to your router, the more workload, the slower performance may decline. Now, here, some routers provide additional functionality. We've kind of talked about them through the course. Firewall capability, even antivirus perhaps, is sometimes part of it. So, and you can find more of that in the book. Now, as previously discussed, though a mobile broadband wireless router users can create a mobile hotspot, that then you essentially become your own router. Okay. All right. Now, communications devices continued. So to connect to a network, a computer is going to use a NIC card. A NIC. Sometimes we say NIC card, but that's repetitive. It's a NIC. It's a network interface card. A NIC controls the wired and wireless connections of a computer, so we can exchange information with other computers and with the internet. So here's a picture of a NIC. If you have a desktop at home or at work, you would look for where you plug in it's the port for the cable as shown in the picture. Now, interconnecting these many types of networks requires various communications devices. As we've been talking, we continue that conversation. A hub or even a switch, which are different things, they provide central point for cables. Now, a hub, as shown in this picture, is known as a physical layer. That's beyond the course. Those are OSI layers, right? So the hub is the physical layer of a networking device, which is used to connect multiple devices together. You see that in the picture on the slide. They're generally used to connect computers in a LAN. A hub has many ports in it, and a computer which intends to be connected to the internet is to the network rather, is plugged into one of these ports. Now, for this is a good picture to include it on the end of course home network project. Might be a good centerpiece, right? Or maybe you'll find a place for it. That's up to you. I just throw that out there. Pages 10-24 and 10-25 will have more ideas for your course project, right? So for example, a modem is going to connect to an internet service provider, and it's going to establish that internet connection for the network in your home. And the router is going to establish the connection between the internet and all the computers, right? And also enables the devices to communicate with one another. And a wireless access point, which your router can also be a wireless access point, you notice those antennas on the back, often includes, allows you to connect the wireless devices together. So transmission media carries one or more communication signals, and broadband will transmit them simultaneously. I did want to mention latency. Latency can become a problem for me at work, so I monitor it regularly. Network latency is the time it takes the data or a request to go from the source to the destination, such as the client to the server. Latency in networks is measured in milliseconds. And there are some easy ways to reduce network latency even on your home network. So you don't have to worry about slow download speeds and lag, right? You want to use a wired connection if you're having serious latency. You can reboot your network hardware. You can close the bandwidth of intensive programs. So if you got a program that's eating up a lot of bandwidth, shut it down. You could disable your firewalls, not recommended, but you can. You can bypass faulty network hardware, and otherwise you may contact your internet service provider as a public service announcement. Now, continue with transmission media. This figure on the left shows a simplified example of sending a request over the internet using a variety of transmission media, all in a single slide. This is taken from the book. You can review it there. Now, Physical transmission media use wire, cable, and even other material, even glass is used. It's called fiber optics to send communication signals. So physical transition media used in communications include things like twisted pair cable, coaxial cable, which is cable TV, and fiber optic cable, which cable TV companies use to transmit your data quickly. Now, these cables are typically used within and underground and between buildings. Your Ethernet and token ring LANs, for example, often use physical transmission media. Optical fibers are the most secure of all of these transmission media. Installation and maintenance can be difficult and costly. Now, fiber optic cables, they have the greatest transmission speed, highest bandwidth, and the signal can travel longer distances when compared to coax cable or twisted pair. This is covered again in detail on pages 1027 and 1028. Now, the use of two wires twisted together helps to reduce interference or crosstalk and electromagnetic induction, it's called, right? So while twisted pair cable is used by older telephone networks and is the least expensive type of LAN cable, most networks contain some twisted pair cabling at some point along the network still. Now, what is coaxial cable? Coaxial cable, sometimes just called coax, is a type of cable that has an inner conductor surrounded by an insulating layer and surrounded then by a conductive shield, right, or conductive shielding. Many also have an insulating outer jacket. And this diagram illustrates the construction of a typical cable, right? Electrical signals flow through the center of the conductor. So the coax cable is used as a transmission line for radio frequency signals. Its applications include feed lines connecting these various antennas and receivers, computer networks like the Ethernet, digital networks, and even cable television. Our view of a cable television network is on the right, our normal view if we went to our TV right now. Now this slide shows fiber optic cables that send data, digital data at the speed of light. And they do so because they operate by transmitting light through flexible optical pure fibers of glass or even plastic. Each optical fiber strand is about the width of a human hair. Now this slide shows wireless transmission media signals through aerospace and the types and the speed at which they work. Note that infrared is line of sight, like your remote control we mentioned, and that broadcast radio uses IEEE standard of 802.11. We discussed this earlier, and it's used to send radio signals through the air over long distances. Bluetooth, UWB, Wi-Fi technologies, they use these broadcast signals. They're also used for hotspots. Now, cellular radio, in the most basic form, a cell phone is essentially a two-way radio consisting of a radio transmitter and a radio receiver. When you chat with your friend on a cell phone, your phone converts your voice into that digital electrical signal and then transmits it over the radio waves to the nearest cell phone tower. Okay? As a microwave, though, is line of sight wireless communication technology, and it uses high-frequency radio beams of radio waves that provide high-speed wireless connections that can send and receive voice, video, and other information. Now, I will pick it up with communication satellites in about a 4-minute follow-up to conclude Chapter 10 when we come back.